We start by filling a beaker with warm water of about 30 degrees Celsius. This will be our water bath and will ensure that the reaction temperature stays steady throughout the experiment. We measure out 100 milliliters of distilled water in a graduated cylinder. We also measure out 100 milliliters of 0.1 molar potassium iodide solution. And 100 milliliters of a 3% hydrogen peroxide solution. We pour all three solutions into a beaker to mix them. This is our reaction mixture. And we pour this into our water bottle, which is our reaction bottle. We try to fill up the bottle as much as we can. We will have some of the solution left over. Put the top on, make sure the cap is twisted on tightly, and then we clamp this water bottle into our water bath and check the temperature again. This is still our desired 30 degrees. We put a graduated cylinder under the nozzle to catch any liquid that might come out. After a few minutes, we can see the liquid rising inside the nozzle, and then slowly mixture will be expelled into the graduated cylinder. Once we observe a steady flow, we switch over the cylinder to an empty one and start our timer. We collect liquid for a minute. And switch over the graduated cylinder again. We take a reading of the volume that has accumulated in the cylinder and write this volume down on our data sheet. Pour out the cylinder, and after another minute has passed, we switch them over again. This is how we determine the flow rate of volume per minute. In this part, we do not need distilled water. We measure out 100 milliliters of 0.1 molar potassium iodide solution, just like we did in the first part for the standard mixture. And then we measure out 200 milliliters of 3% hydrogen peroxide solution. So this is double the amount of hydrogen peroxide solution than we used in the first part. So in our resulting mixture, the concentration of hydrogen peroxide will be double the initial one. We pour all the reagents into our beaker to mix them, and pour this mixture into our reaction bottle. We twist on the cap tightly and clamp this bottle into our water bath. This should still be at 30 degrees, just like in the first part of the experiment. We put a graduated cylinder under the nozzle to capture the liquid and observe it rising a lot faster than in the first part. Immediately we can observe a faster flow. Once the flow is steady, we switch the cylinders over to an empty one and start our timer. After a minute, we switch over the cylinder again, read the volume and write it down. Again, this is our flow rate of milliliters per minute.